Hello class, today we're going to be doing lesson number 8 on climate change. So I'm just going to introduce the topic and give you an idea of what we're going to do. I gave you a project on Friday where I wanted you to do a research paper or describe 3 photos on weathering. So I'll only give you kind of one question, and I'm just going to give you the answer in the video to make sure you watch the video, so you have some time to work on that project. So climate change is a very big topic, and it was going to be hard to cover it in class fully, even when we're back, even when we were in school, with about a month. So we're going to do our best to kind of give you an overall idea about climate change and kind of give you a full picture about all the ideas out there about climate change in a small amount of time. So I imagine this topic lasting 5 weeks. So that will mean you'll have 15 lessons on it. And we'll try to go through slowly. And I think engagement's really interesting in climate change, and people can have a lot of questions. So I'm going to look at how we can maybe make it a more engaging unit than the rot cycle was. By engaging, I mean I want you to give me some feedback, ask questions, kind of dictate what things you want me to talk about a little bit more. Because it is such a big topic, I'll try to cover everything, but I can't get to everything. So if there's something that you want me to talk about, you're gonna have to let me know. Okay, so the way I imagine us going through this unit is I want to start at the history of how climate has changed over Earth's life. So this will likely start where when the Earth was formed and we were just forming climate, what the climate looked like, how the climate changed to when we had life forming on Earth, how the life changed the climate, and how over time the climate changes from hot to cold, and how that affects life. That's a very big topic, and I want to cover that in maybe a week. So we'll see how we can go through that, and we might have to leave some things out. But just I want to do this to give you an idea of when we look at climate change now. There's so much about how the climate is changing, how this has never happened before. I want to give you an idea of how climate has changed in the past and how it's very different from how climate is changing now. So after we do this, I want to kind of zone in on the last 150 to 200 years, how the climate is changing right now and how it's changed in that past 150 years. So we can kind of study the rapid change that we're experiencing today with the climate. From here, after looking at the change, I want to look at how this change happened, how it's happening, and what effect this change is having on Earth, from animals, plants, humans, the Earth itself. And then from here, I want to look at how we can use science to predict the future, to predict how Earth will look in 500 years, 10 years, 50 years, based on what we're doing today. And then I actually want to make a project out of this, which I'll get more into later. So that will kind of wrap up anything kind of about how the climate is changing. And then I kind of want to finish more about how what we are doing right now to slow down and stop climate change, and what we are not doing. So what we are failing to do that we need to do if we're going to make a big difference. And I want to try my best to take a science approach to this topic. But I think it'd be interesting as well to look at the politics maybe behind this in like a short lesson, to look at why these changes maybe aren't taking place. All right, so that's everything I want to cover. And as it is a science class, I think it'd be really interesting to look at some data for this. Now, initially what I wanted to do is there's a whole bunch of weather data in Victoria from all the schools in Victoria. And we can actually analyze it to see how the temperature has changed year to year in Victoria. So I thought this would be cool for you to do, but it's not really feasible now. So what I might do is one of the lessons, I'll run through some data analysis, and kind of give you an idea of what people are doing to analyze data and how data is being analyzed, and how looking at a bunch of data, it can tell us about what's going to happen and what is happening in a very non-biased way. So what I mean by data, there can be anything from looking at the chemical component of the air for air pollution, looking at the temperature itself over time. So the data that we would look at is every minute inventory for the last 15 years, schools have been recording the temperature. And then that temperature gets put into a file, and you get a ton of data on every minute how the temperature changes. So you get probably millions to maybe even a billion bits of data, and you break it down, analyze it, so it can tell you how things change. So there'll be a bit of math in this, and I might have you do a little bit of math in the assignments, or at least try, but it will be easier and more straightforward than the calculations we did on gravity. And I know some of you are concerned about math, which is fair. So I'll make sure that it's not anything that's going to cause any more stress. Okay, so this brings us to the final project. And right now it's still at the early stages, but I thought I'd give you an idea of what the final project would be, just so you have a sense of how the course is looking to end. So I don't want to finish on a test. I feel like at this point, a test wouldn't be helpful to anybody. I don't think you would want to study for a test. I don't think it would be helpful to have the stress of a test, or even for me to mark the test. I don't know if it would really assess what I want to assess. So what I want to do for kind of the end of the course is have a final project. So this will be similar to the project you're doing right now on weathering. Might be a little bit bigger, and I want to focus more on conceptual ideas than like facts. Well, yeah, you need facts as well, but using these facts to get ideas, to form ideas. So we covered astronomy, plate tectonics, rock cycle, and climate change. And we're also going to look at the water cycle at the end of the course. So based on these 5 topics that we've covered or covering, I want you to, on the final project, is to choose one of those topics and write a research report on how we can use the research we're doing on that topic to shape the future. So if we're looking at climate change, you can look at what we are doing now and what we're going to be doing in the future to stop climate change, or you can look at how climate change is going to affect our future. For astronomy, you could look at space travel if you wanted to. You could look at what research is going on now, or what research is being proposed for the future, for what possibilities lie ahead. Or for plate tectonics, you could predict how the plate tectonics are moving, see how will that affect how Earth ends up, or the future of Earth. So it's pretty not very structured right now. I'll put some more structure into it by the time we have the project come up. I just wanted to give you an idea of what the end of the course is going to look like, because people have been having a lot of questions about that. Okay, so for today, because it is a lesson, I just thought it'd be interesting for you to see some of the main causes of climate change, and if they're natural, human caused, or if they're a bit of both. So I put together a list of 9 factors that are going to be the main ones we're going to look at. There's definitely a lot more, but these are just the ones that we have time to really focus on. If there is a factor that you want to explore more, please let me know and we can add it in. So by natural caused or natural effects on climate change, I mean things that happen without human interacting with whatever that is. So the first one is how much energy reaches Earth, or how much energy from the sun reaches Earth. So what happens is, as the sun's rays or the sunlight energy hits Earth, it's going to warm Earth up. And that warming of Earth up increases temperature. So if Earth is closer to the sun, it's going to have more energy from the sun hitting Earth. Or if the sun gets bigger or the sun is hotter, we're going to have more energy hitting Earth. There's also volcanic eruptions. So volcanic eruptions are actually really interesting. If you have a massive volcanic eruption, you get ash and dust put into the atmosphere, and it makes the atmosphere very black. So it blots a lot of the sunlight from getting in. So you can actually get like a volcanic winter that can last like years, where because no sunlight's getting in, the atmosphere just cools very quickly. So over massive volcanoes, it can put or it can start like an ice age on Earth, somewhat. Not like a full ice age, but like it can really cool down Earth a bunch. And then ocean currents have a huge effect on the climate as well. If ocean currents change, and say you get cold air coming in from the Arctic down into more along the equator, it can really cool the equator. Or if you have hot water in currents up to the Arctic, it can really warm up the Arctic. So ocean currents play a big part in how our climate is. Looking at human-caused things, deforestation is a big cause of why there's less trees around to not only reduce the greenhouse gases, but also it changes Earth's reflectivity, which means it's going to absorb more light and warm up more. There's also water and air pollution, and then destroying the ozone layer, which is going to block some of that harmful light coming in from the sun. So it's more energy from the sun getting to Earth. For both, there's the reflectivity of Earth's atmosphere and the surface. So if you have a very dark or black part of Earth, it's going to absorb more light, which means that it's going to heat up more. If you have a very white surface, it's going to reflect more light and it's not going to get as hot. So in India, what they're doing, because it was so hot, the roads were melting people's shoes, they actually painted the roads white. And that cooled the roads down by about 5 to 10 degrees Celsius, just by painting them a different color and changing the reflectivity. Then there's greenhouse gases. This is mostly done by humans with deforestation, putting more fossil fuels into the air. But then there's also natural greenhouse gases like water vapor. Or there's planets like Venus. What happens to Venus is it actually is hotter than Mercury, even though it's further away from the sun, because they have what we call a runaway greenhouse effect, where there's just so much gas in the environment that it warmed up Earth, and that warming up, warmed up Venus, and that warming up of Venus actually produced more of the greenhouse gases into the atmosphere, where it just got really, really hot and kept getting hotter until it reached like its maximum. And then there's water levels and surface ice. So humans will affect water levels by warming up the atmosphere. But then based on Earth's climate as well, that's not human caused, things can cool and things can heat. So the more surface ice or the higher the water levels, it actually reduces greenhouse gases because water will absorb some of the greenhouse gases, and it also changes Earth's reflectivity. So they'll also change how much heat Earth is absorbing. So those are just 9 points that kind of give you an idea of what we're going to be looking at for how the effects of climate change. There's definitely a lot more out there. So like I said, if you have any ideas that you want us to cover, just let me know and we can add it in there. All right, hope you all have a great day. Good luck working on the project. Oh, I almost forgot. The answer to the question is banana. Bye.